Assalamu alaikum, welcome to my presentation of my poster. In the introduction, in this project, the process of nuclear fusion in stars was explored. Stars were studied as places where elements are created and released into space. The objective of this project was to create a model showing how different elements are formed in stars through nuclear fusion, elements such as helium and hydrogen, and to explain the physical and chemical life changes stars go through during their life cycle. Chemical and physical changes were noted. Chemical-like changes were shown by the way protons and neutrons were fused to form new elements, like helium and carbon. Physical changes were shown through the different star stages, such as when a star expands into a red giant or explodes as a supernova. In the analysis, it was shown that nuclear fusion happens in the core of stars, starting with hydrogen atoms fusing into helium. In larger stars, fusion continues, creating heavier elements like carbon, oxygen, and iron. The model also helps show how a star's mass decides its path. Low mass stars end as white dwarfs, and high mass stars can end as neutron stars or black holes. Methodology. The model was made using styrofoam and clay to represent protons and neutrons. Magnets were used to show the strong nuclear force. 2 star life cycles were shown, one for low mass stars and one for high mass stars. A triangular structure was used to explain the triple alpha process, and labels were added to explain each stage and reaction. Results and findings. It was found that nuclear fusion powers stars and creates most elements in the universe. The model clearly showed the fusion process and helped compare physical changes like expansion with chemical-like changes like fusion. It was also understood that the star's mass controls its entire life cycle and final outcome. Conclusion. This project made it easier to understand how stars live, change, and die while creating the elements that make our planets and life. Building the model helps show these complex ideas in a clear and creative way. In my poster, I explained and connected the model to our title and our topic and how they correlate with each other. On my poster, the last 2 images were diagrams. And in the diagrams, I showed the star's life cycle. It first starts off as a nebula, a dense region. The nebula begins to shrink, warm up, and become a protostar. In the main sequence star, this is where the mass decides if it will be a low mass star or a high mass star. In the low mass star, after the main sequence stage, it becomes a red giant. Stars of less mass expands and glows red as it cools. After this stage, the outer layers of gas puff off, resulting in a planetary nebula. Hot core will be exposed as a white dwarf. After the white dwarf stage, the star cools and reddens, becoming white dwarf cooling. Then the star completely stops glowing, resulting in a black dwarf. For high mass stars, after the main sequence stage, stars of greater mass expands, cools, and turns red, resulting in a supergiant. After the supergiant stage, it becomes a supernova. The supergiant explodes, blasting away outer layers. After the supernova stage, the core collapses and becomes very, very dense. Then this is called a neutron star. The core collapses in the neutron star completely and vanishes, thus resulting in a black hole. Thank you for listening to my poster presentation.